day, folks. Welcome to my YouTube channel. Today we're going to look at the examples of the resolution of a vector. If you check my previous video, I've mentioned what is the resolution of vector. Now let's look at this example. Calculate the vertical and the horizontal component of a 350 Newton force pushing downwards. This is supposed to be downwards, guys, not upwards. Downwards the lawn mower at an angle of 33 degrees to the horizontal. This is supposed to be downwards because you see it's pushed downwards, right? Now to do that, guys, it's very important in the diagram to understand what is happening there. So if you have a force that is pushed at an angle, you have two forces, the two components, which is the vertical component, that will be Fy, and the horizontal component that is going that way, which is your Fx. So now, using the formulas, calculating your Fx is going to be F cos theta. What is the magnitude? The magnitude is 350 cos 33 degrees, and then you punch that in your calculator. So it's going to be 293.53 newtons. And where is it going? If you see in the diagram, it's going to the left. And then we calculate the vertical component. Vertical component, its formula, it's F sine theta, which is going to be 350 sine 33 degrees. So it's going to be 190.62 newtons, and it's going way downwards, as you can see in the diagram. It's going downwards, right? That's how you calculate that. Let's look at the second example. The second example here, it says calculate the vertical and horizontal component of a 290 force pulling. It's not supposed to be pushing, it's supposed to be pulling. There, guys, it's supposed to be pulling. Let me fix it. It's pulling upwards, the cut at an angle of 30 degrees to the horizontal. So if they say the force is 30 degrees to the horizontal, that means that the angle 30 is here. If they were saying a 30 to the vertical, it was going to be here, the 30. But to the horizontal, that means it's between the horizontal and that force. So this force is 290, the force applied to the horizontal. That means it's between the horizontal force and that. I hope that makes sense. Now it's very important to know here what will be your components there. You have your Fx there, will be going to the right in that way, and then you have your Fy upwards like that, your Fy, and then calculating the two, the horizontal component, your Fx cos theta, and then it's going to be 290 cos, what is the angle? It's 30. 290 cos 30. Punching that in the calculator, it will be 290 cos 30. Okay, punching that quickly in the calculator, it will be 290 cos 30. So it will be 251.15 newtons. Where is it going? To the right. And then punching the sine, which is the vertical. Now calculating the vertical, it's going to be Fy is equal to F sine theta. So your force there, it's 290 sine 30. So it will be 145 newtons upwards. Upwards, as you can see, it's going upwards. That's how basically you calculate the components in resolution of a vector. Let's look at it, guys. If it was a different example, now a different example, they said calculate the vertical and horizontal component of a pulling force upwards the cut at an angle of 45. Now the angle is 45 degrees to the vertical. It's very important. When I say to the vertical, that means the angle is between this force and the vertical component, so the 45 is going to be there. So the angle, when they say to the vertical, is between the vertical and that. So now always the angle that we use there, it's this one. So you were going to say 90. This is 90. 90 minus 45, it's going to be 45 there. So we're going to use that. And then our components there, you have your fx there and your fy there. Right? So we were going to say your fy is f sine theta. And then we substitute. There, substituting our values. Remember, we have 294 sine what? 45 degrees. So punching that, it's 290 sine 45. So it will be 205,06 newtons, and where it's going? Upwards. And then calculating the horizontal, your fx is f cos theta, and then it's going to be 290 cos 45 degrees. So punching that in the calculator, it will be the same answer. 205 0.06 newtons, and your x is going to the right. I hope you get the difference between the previous answer and this.